All right, everyone. The problem says, what is the number of significant figures in each of the following measurements? So we are looking at sig figs and counting them up for each of these different measurements. So we have our sig fig rules over to the right. That's what we're going to use to help us solve the problems. So looking at A, we have 4,867 miles. So how many sig figs are in that measurement? Well, this one should be pretty easy. 4, 8, 6, and 7 are all non-zeros, and rule 1 says all non-zeros are significant. So we have 4 significant figures for A. Okay, let's look at B. We have 56 milliliters. Well, again, neither 5 or 6 is a 0, so they are both significant by rule number 1. So for B, we will have 2 sig figs. Okay, C, we have 60,104 tons. So the 6, the 1, and the 4 are all significant. What about the zeros? Looking at rule number 2, we know that zeros in between sig figs are significant. So because this first 0 is in between the 6 and the 1, and those are significant, that 0 is significant. And the second 0 is in between the 1 and the 4, and they're both significant, so it must be 2. So all of these 5 digits are significant, so we have 5 sig figs for C. All right, D, we have 2,900 grams. So the 2 and the 9 are significant. What about the zeros? Looking at rule number 4, we have zeros to the right of a sig fig are not significant if there isn't a decimal point. So we have these zeros here, and they are to the right of the 9, which is significant, but there is no decimal point here, and that's where it would be if there was one. So that means that these zeros are not significant. We don't know for sure what they are. We had to put them there so that we could write the 2 and the 9, or otherwise known as placeholders. So we're going to have 2 sig figs for D. Now, if that number was written as 2900 decimal point, that would mean that these zeros are significant, because zeros to the right of a sig fig are significant if there is a decimal point. So rule number 5 would apply to 2,900 decimal point, because those zeros would be significant in that instance. We're putting that decimal point there because we're saying we know those are zeros for sure. Okay, let's look at E, 40.2 grams per centimeter cubed. So we have the 4, we have the 2. What about the 0 in between? Well, that's easy. That's rule number 2. That means that 0 is significant. So we have 3 sig figs for E. All right, F, 0.00000003 centimeters. Well, we know the 3 is significant. What about all these zeros to the left? Well, zeros to the left, that is rule number 3. Zeros to the left of a sig fig are not significant. So all of these zeros to the left, none of these are significant. We just have to put them there as placeholders, because without them, we wouldn't be able to write the 3 right there. So those are just placeholders. For F, we only have 1 sig fig. All right, 2 more. We got G, 0.7 minutes. So the 7 is going to be significant, and very similar to the last measurement we looked at, we have a 0 to the left. That means we're looking at rule number 3, where zeros to the left are never significant. So that 0 is not significant. We just need it there to write the 0.7. So for G, 1 significant figure. For the last measurement, we have 4.6 times 10 to the 19th atoms. So hopefully you're recognizing that this number is in scientific notation, where we have a number times 10 to some power. That is scientific notation. So with scientific notation, it's really easy to know how many significant figures you have, because whatever is in front of the times 10 to the power must all contain significant figures. So the 4 and the 6 are both significant. We don't have to look at any rules. We know that those are both significant. So for H, we are going to have 2 sig figs. For a quick similar example to H, let's say we had 4.60 times 10 to the 19th. So we have this extra 0 here. How many sig figs would we have? Well, again, we're in scientific notation, so whatever number is in front of the times 10 to whatever power must be significant. So here we would have 3 sig figs. All right, there you have it, determining the number of sig figs in each of the following measurements. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.